Hi class, in this lesson we're going to talk about a type of rigid motion transformation called reflection, and at the end of this lesson you will learn to draw and describe the reflection of a figure across a line of reflection. So before we get started, let's go ahead and define what a rigid motion transformation is. So in essence, a rigid motion is a transformation that preserves or keeps the length and angle measure of the figure. So let's take a look at an example. So here we have two figures, figure A and figure B. Figure A and B are considered rigid motion transformation because both the length of the sides of that figure and the angle measures are exactly the same. Okay, so the only difference here is that angle B is a little bit rotated from angle A. Otherwise, everything is the same. Okay, now in this next example, object A versus object C, these are not considered rigid motion because with object C, although the angles are exactly the same as that of object A, the sides are longer. Okay, you could see visually that object C is a larger proportion, and so that is not a rigid motion transformation. Okay, let's move on to a figure that is reflected on a coordinate plane across the x-axis. Okay, here we have a quadrilateral ABCD on a coordinate plane, and what we're going to do is reflect this object across the x-axis. So how do we do that? Let's take a look at point A. Okay, point A is exactly 2 intervals above the x-axis, and so what we want to do is draw its reflection 2 intervals in the opposite direction from the x-axis. So it'll be 1, 2. So we will plot a point right here and call it A prime. Okay, now we're going to look at the next point here, point B. Okay, we're going to see or determine how many intervals B is away from the x-axis. Okay, so it'll be 1, 2, 3, 4. So it's 4 intervals. So we're going to go 4 intervals in the opposite direction for B prime. 1, 2, 3, 4. Okay, so we're going to put a point there and label that B prime. Okay, so next we're going to move on to point C, and we see that point C is 2 intervals above the x-axis, so we're going to go 2 intervals below that and plot a point and label that C prime. Okay, and then the last point, point D. Point D is on the x-axis, so there's really no interval away from the x-axis, so we will go ahead and plot a point, the same exact point, and just label it D prime. Okay, now that we have those 4 points, we can go ahead and connect the points, and we're going to do that in order from A prime to B prime, and then to C prime, to D prime, and then back to A prime. Okay, and there we have the object reflected off the x-axis. So ABCD is reflected off of the x-axis, and now we have A prime, B prime, C prime, D prime. Okay, so let's look into what's happened a little bit deeper and compare the coordinates and see if we can find a pattern and maybe find some sort of way to reflect points or objects a little bit faster than having to count all of these intervals. Okay, so let's go ahead and put the points down for ABCD. Okay, so here I've got listed point A as -2, 2, point B as 2, 4, point C as 4, 2, and then point D as 2, 0. And now we're going to do the same thing for A prime, B prime, C prime, D prime. Okay, so here are our points for A prime, B prime, C prime, and D prime. So if you were to take a look and compare, let's say A to A prime, okay, and you look at the coordinates, you notice that the x value remains the same. The y value almost remains the same. Okay, what we have is that with the prime, the y value is actually the opposite, or negative, right? So here we've got 2, this is negative 2. Now let's take a look at b versus b prime. So the x value remains the same, they're both 2, but this time the y value is the opposite of what the original point was, right? We have 4 versus negative 4, okay? So we're beginning to see a pattern. The x's remain the same, okay? X's remain the same, but the y values become negative. So does that hold true for the other 2 points? Well, let's take a look. Our x value here is 4. Over here it's also 4 for C prime. And then the y value here is 2. Well, what's the opposite of 2? It's negative 2, okay? So this seems to be holding true. And then the last point, point D versus D prime, our x value is 2, okay? So that remains the same. And then our y value, although it remains the same, we need to recognize that the opposite of 0, or negative 0, is still 0, okay? So that pattern holds true. So what are we saying here? So what we're saying here is that any point, okay, that is reflected across the x-axis, so that's this axis right here, whenever it's reflected across the x-axis, the resulting image, right, the coordinate of the resulting image is the same, except the y value is negated, or negative. Okay, let's go ahead and take a look at what happens when an object is reflected not across the x-axis, but now across the y-axis. Okay, here we have another quadrilateral ABCD, and now we're going to reflect this across the y-axis. Okay, the y-axis is right here. So how do we do that? Let's go ahead and count the number of intervals that point A is away from the y-axis. Okay, so it'll be 1, 2, 3, 4. And so the reflection of that will be 4 intervals away from the y-axis in the opposite direction. So it'll be 1, 2, 3, 4. So we'll go ahead and plot a point there, and we'll label it A prime. Okay, so let's go ahead and do that for point B. All right, point B is 3 intervals away from the y-axis, 1, 2, 3. And so we're going to go in the opposite direction, 1, 2, 3, and label that B prime. All right, continuing on with point C. Okay, point C is right on the y-axis, and there's no interval away from it, and so C prime will be that same exact point. So we'll go ahead and label that as well. Okay, and then lastly we have point D. Point D is 2 intervals away from the y-axis, 1, 2. So we're going to go in the opposite direction, 1, 2, and label that as D prime. Okay, now we're going to connect the dots, and we're going to do this in order. We're going to go from A prime to B prime, B prime to C prime, C prime to D prime, and then D prime back to A prime. Okay, so there we see the reflected figure, and visually it looks like A prime, B prime, C prime, D prime is a reflection of A, B, C, D across the y-axis. Okay, so let's take a look at the coordinates and do some comparison and see if we can summarize similar to what we did in the previous example. Okay, so for quadrilateral ABCD, we have identified point A as negative 4, 2. Point B is negative 3, 5. Point C is 0, 4. And then point D is negative 2, 1. So we're going to do the same thing for the reflected image, A prime, B prime, C prime, D prime. Okay, so those are the points for A prime, B prime, C prime, D prime. Now, let's go ahead and compare A versus A prime, okay? What we notice is that the x value is not the same, but it's the opposite, right? Negative 4 versus 4. However, the y value this time are the same. We have 2 and 2, okay? So now what we're seeing is that the x value is the opposite, but then the y values are the same. So let's see if that holds true. So let's take a look at B versus B prime. Well, see the x value here, negative 3 versus 3, all right? So 3 is the opposite of negative 3. However, in the y values, 5 versus 5, they're exactly the same. Okay, let's take a look at C and C prime. C and C prime, they're exactly the same. Okay, however, again, if we take the opposite of 0 or the negative 0, it's still 0. Okay, and then the y values of 4 versus 4, they're exactly the same. So the pattern seems to be holding true. Let's take a look at the last one. D versus D prime. Okay, the x value of negative 2 versus 2, it's the opposite. We have an opposite situation going on. And then the y values, they're exactly the same. Okay, so I think we could safely say that when an object is reflected across the y-axis, okay, so this vertical line here, or vertical axis, the x values change, right? Change to the opposite, but the y values are exactly the same. So let's go ahead and summarize that statement. Okay, so when any point xy is reflected across the y-axis this time, okay, its reflected image has the coordinate negative x comma y. Okay, so an easier way to remember this is whatever the axis is being reflected, okay, that's the value that stays exactly the same, and then the other value is the opposite. Okay, so hopefully that made sense to you. If any of this was not clear, please go back to the beginning of the recording and listen to it again. Thank you.